This section is 2.3 on real zeros of polynomial functions. So basically in this section, we're going to be doing different types of division of polynomials and use it to find real zeros. So the first thing we're going to talk about is the division algorithm. So this algorithm says if fx and d of x are polynomials such that d of x is not equal to 0, and the degree of dx is less than or equal to the degree of fx, there is a unique polynomial, qx and rx, such that, and they give us this formula. That's a lot of mathematical language, basically to say this is going to be the nice way that we write our equation at the end when we divide polynomials. So f of x equals d of x, so that's going to be our divisor times the quotient, so that will be the answer we get at the very end, plus the remainder. So once again, we have the divisor as d of x and the quotient as q of x. And then r of x is the remainder. So if we use that in the example given here, divide x squared plus 3x plus 5 by x plus 1, we're going to do this using long division. And anything that we're dividing by, so divide this by this, that is our divisor. So this is our d of x. And the divisor goes on the outside of our division bracket. Okay, so our divisor goes on the outside, our f of x goes on the inside, which is what we're dividing the divisor by. And so here we're going to take a look just at our first terms. So we're just going to start with x and x squared. And we ask ourselves, x times what gives me x squared? X times x. So that would be the first thing I write on top of my division bar. And what I'm going to do now, so x times x gives me x squared. I'm going to multiply this value by both in the divisor. So I get x squared plus 1x. And then following regular division rules, we subtract. And so not only am I subtracting x squared, I'm also subtracting x. So these cancel, which is the point. And then 3x minus x, I'm left with 2x. And we can bring down the plus 5. So now I'm going to compare x and 2x. And I think to myself, x times what gives me 2x? X times 2. So positive 2 goes on top. And notice I'm lining up all of my x's, all of my x squareds, and all of my numbers. You want to keep everything in order. So 2 times x is 2x. And 2 times 1 is positive 1. And here is where subtract, subtract. 2x's cancel out. And I get 5 minus 1 is 4. So now this number 4 is my remainder. So this is Rx. The answer we got on the top is the quotient, so that is Qx. And using the division algorithm to write this out, we're going to write it in this form. So we can write f of x equals x plus 1 times x plus 2 and plus 4, because that's my remainder. And so this would be my final answer. And so essentially what this means is this that we started with is equal to if we FOILed out x plus 1 times x plus 2 and then added 4 on at the end. So in this first example, we had a remainder. When you don't have a remainder, that means that you can actually factor out the polynomial completely using division. So as you can see up here, our final answer kind of looked like two sets of factors, but then we had this plus 4 on the end. So if we didn't have a remainder, this would be factoring our original f of x equation. So in this example, our remainder is going to end up being 0, and sometimes you can even factor out your answer further. So I'll show you an example of that now. So once again, when we set this up, whatever we're dividing by, that is our divisor. So that is d of x, and that goes on the outside of not parentheses, outside of the division bar, and then our f of x function. So this goes on the inside. 6x to the third minus 19x squared plus 16x minus 4. Okay. So once again, we're going to look at x and compare it to 6x to the third. What do we need to multiply x by to get 6x to the third? We need to multiply it by 6x squared. So I'm going to write 6x squared in the x squared column above my division bar. And then I'm going to multiply 6x squared by both of these terms. So I get 6x cubed minus 12x squared. Subtract. This becomes addition because double negative. Here, these cancel. And then negative 19x squared plus 12x squared gives us negative 7x squared. And we bring everything down. So now from here, we want to look at x, and we want to compare it to negative 7x squared. What do I need to multiply by? Here, I need to multiply by negative 7x. So I write minus 7x up at the top, and then I multiply this by both of my terms. So I get negative 7x squared plus 14x. And then I subtract, so that would be double negative becomes plus, and then minus 14x. These cancel. 16x minus 14x, I'm left with 2x, and I bring down the minus 4. So now here, we're going to compare x, once again, to 2x. What do I need to multiply by? Multiply x by to get 2x. I need to multiply x by 2. So I put plus 2 up at the top. Multiply 2 by both of my terms. I get 2x minus 4. Subtract, plus these cancel, we're left with a remainder of 0. So now using the algorithm at the top, we are going to write this as f of x equals d of x times q of x plus r of x, which is going to be 0. So once again, we have f of x equals my divisor, which was x minus 2, minus 2, and then times my quotient, which was 6x squared minus 7x plus 2. So So now, as you can see here, we have two factors, but if we take a look at this factor, we can actually factor this further. And in order to do that, we need to break it up into two more factors. So the reason we have to factor it further is because it said to factor the polynomial completely. So because this is still factorable, this would not be completely factored out. So what we're going to do is say equals x minus 2 fully factored, and then we're going to break up this polynomial to be factored further. So we are going to test out 3x and 2x because 3x times 2x is 6x squared. Um, Something else we could try out is 6x and 1x and see if that works. But we're going to start with 3x and 2x. So now keep in mind, whatever is over here and whatever is in here, that all has to, those two pieces multiplied have to add together to be negative 7x. So we want factors of 2. So that would be 2 and 1. So let's just try out 2 and 1. And because this is a minus and this is a plus, so we're adding to a negative, multiplying to a positive, we know that the sign is going to be a double negative for both. So here we have 3x minus 1 and 2x minus 2. So negative 2 times 2x would be negative 2x, and 3x times negative 2 would be negative 6x, which this combined does not equal negative 7x. So we need to pick something else. So let's switch them. We'll switch this to 1, this to 2. So now I have negative 2 times 2x, I get negative 4x. 3x times negative 1, negative 3x. When we add them together, we get negative 7x. So here are my two factors, and this is now factored completely.